Alright, so I want to make a video about some advanced angle relationships, but also the way that we identify angles when we're talking about them, how we like call an angle what we call it and why we call it what we call it. Alright, so let's use these three lines that make up like a triangle to demonstrate what I'm talking about. Okay, so those are three lines, and we'll call this point A, call this point B, we'll call this point C, and they are all on one plane. And they all intersect, so none of them are parallel. And it doesn't look like any of them are perpendicular because we don't have a little square. Okay, so let's, we could very easily just say, hey, this is angle A, this is angle B, and this is angle C. But, you know, what about these outside angles over here, right? So, say we had like Y and Z, and then we had X and W, right? And then we had V and, I don't know, V and I used X, M, why not? Okay, all right. So if now we can't really call this angle A, right? Because which angle are you talking about? Are you talking about this angle? Are you talking about that angle, that angle, that angle, right? So, and same as all these, right? So we use a three-letter system, right, to identify angles. So let's talk about this inside angle right here. We'll call it angle. This is angle BAC. Right, that's angle BAC. It could also be CAB, but what's important is that middle letter is the vertex. All right, this angle here, right, this is angle ABC. Angle ABC. It could be CBA, right? But what is important is that middle letter is the vertex. And then we'll say that this letter, this one here, we'll give it three lines. All right, this is angle ACB, right? Or angle BCA, with C being the middle letter. Okay, and then out here we have VBM, which is congruent to ABC, right? Because they're vertical angles. And then we have ZAY is congruent to BAC. They're vertical angles, right? And then this angle XCW is congruent to ACB there. And notice how I looked, this has like a 3 Wi-Fi bar symbol, right? This is a 2 Wi-Fi bar symbol. It's a 1 Wi-Fi bar symbol, right? Those are different ways to differentiate angles, okay? We can also use Greek letters because Greek letters are, you know, funny shaped, and sometimes it's easier to identify them. So some common ones to use are like, instead of saying BAC, we can call this angle theta, right? This is common theta, right? It's like a set of parentheses with a slot through it, okay? Right, we can, that's angle theta. Then there's angle, we could call this one angle sigma, right? That's angle sigma. That's a lowercase sigma. And these are all lowercase, but that doesn't really matter. It makes much of a difference, right? So that's lowercase sigma. And then you could call this one like lambda. Looks like that. And this is lambda, LAMBDA. All right, so those are three common Greek letters that can be used. Sometimes I like to use epsilon. We'll call like this angle ABV. We'll call this like angle epsilon because it sounds funny. It's like a cursive E, right? It's epsilon, right? If we really need four of them, right? And there's a bunch of other ones too, right? But you can use these Greek letters, and we will be using theta a lot, and when we get to Unit 7, right, trigonometry. But you can become accustomed, because saying angle theta is a little bit easier than saying angle BAC, right, or angle A if we only had one angle to consider. Okay, so something a little bit new topic. I want to talk about bisectors, angle bisectors. Right, so say I have an angle like this, and we'll call this, that's point M, right, and we'll call this AC, right? You could call this angle theta if you wanted to, but this is angle AMC, right? AMC, this angle right here, right? Now, if I have an angle, a line that bisects this angle, if I have a ray or a line, right, we'll call this B, right? Point. I'm gonna make some points here. Okay, that's angle. Now we'll say that it doesn't look like it, but say that it does, right? Because that's how it works. We'll say that ray BM bisects angle AMC. It means it splits it exactly in half. Kind of like a midpoint for a line segment, but for angles instead. Now, it doesn't look like I did it right here, but it doesn't matter what it looks like. It matters what the given is said, right? So if this bisects it, that means that this angle, this blue one, and this blue one, angle AMB, angle AMB has the same measure, or is congruent to angle BMC, or CMB. Okay, or you could say, hey, this is angle theta, this is angle lambda. You can say angle lambda is congruent to angle lambda, right, if you wanted to, right? I'm good with it. Okay, so that's what a bisector is. Okay, now let's say we have a straight angle like this. I'll go ahead in a second. All right, we have a straight angle like this. Point A and point B, and there's an M right here, right? And we'll say that angle, this is M. You'll see why I named it M for in a second. And we'll call this point C, right? So we're going to say that angle AMB is 180 degrees, where the measure of angle AMB is 180 degrees. Therefore, it's a straight angle. You already know that. But we're also going to say that CM, the ray CM, is a perpendicular bisector of angle AMB. That means that this does two things. It bisects line AB, making point M the endpoint. Therefore, M is midpoint of AB, line segment AB, right? And angle AMC is the measure of angle AMC is 90 degrees. And the angle of CMB is 90 degrees. You can also say this is theta, this is lambda. You can say that theta equals lambda equals 90 degrees, right? And because it's a midpoint, you can say that AM is congruent to MB. Right, so that's a lot of stuff to say when you have a perpendicular bisector. Perpendicular bisector. Okay, pretty important thing there. It's nice to know. All right, hopefully that makes a lot of sense and you learned some stuff.